Have you ever looked up at the night sky and wondered, where did all of this come from? How did it begin? These questions connect us to our earliest ancestors, who gazed at the same stars and wondered the same things. The universe doesn't come with instructions, so we piece together its story from the clues scattered across space and time. Our quest to understand the cosmos is the universe trying to understand itself, because the atoms in our bodies were forged in ancient stars. For most of history, answers came from myths and philosophy, but with the scientific method we began to read the universe's diary through telescopes and mathematics. The journey to the Big Bang Theory was anything but straightforward. It forced us to abandon old beliefs and embrace ideas that defy intuition, like a universe with a beginning, still expanding today. The story of the Big Bang is not just about the universe, it's about how we learn to let evidence, not comfort, guide our understanding. And it all started with a simple, elegant, and ultimately wrong idea. For centuries, scientists like Newton believed the universe was static and eternal, a cosmic clockwork that had always existed. This static universe model was comfortable and avoided the messy question of a beginning. Even Einstein, when his equations suggested a dynamic universe, added a cosmological constant to force it to be static. The cosmos was seen as a vast, unchanging expanse, with stars and galaxies fixed in place. The idea of a universal birthday sounded more like myth than science. But science is about challenging assumptions. No matter how elegant, an idea must face the test of evidence. The static universe, for all its appeal, was about to be overturned. A series of discoveries would soon reveal that the universe is not a quiet, eternal stage. Instead, it's dynamic, evolving, and far stranger than anyone imagined. The curtain was about to rise on a new cosmic drama. The comfort of permanence was about to give way to the shock of change. The universe, it turned out, was not content to simply exist. It was on the move. And the evidence for this revolution would come from a single, powerful observation. The stage was set for a paradigm shift. The universe's true story was about to unfold. Enter Edwin Hubble, the astronomer who shattered the static universe. In the 1920s, Hubble used the world's most powerful telescope to prove that spiral nebulae were actually distant galaxies, making the universe far bigger than we'd imagined. But his real breakthrough came when he measured the light from these galaxies and found it was redshifted, evidence they were moving away from us. The farther a galaxy, the faster it recedes. This became Hubble's law. The universe wasn't static, it was expanding. Imagine raisin bread rising in the oven. As the dough expands, every raisin moves away from every other. Space itself was stretching, carrying galaxies apart. Even Einstein admitted his biggest blunder was forcing his equations to fit a static universe. If the universe is expanding now, it must have been smaller in the past. Run the clock backward and everything converges to a single, dense, hot point. This was the first observational evidence for a universe with a beginning. The implications were staggering. All matter, energy, and space itself originated from a single moment. The static universe was dead. The cosmos was alive, dynamic, and growing, and the search for its origin had truly begun. While Hubble provided the evidence, Georges Lemaître, a Belgian priest and physicist, had already proposed the theory. In 1927, Lemaître suggested the universe began from a primeval atom, a single, dense point that expanded to become everything. At first his idea was dismissed. Even Einstein called it abominable physics. But Hubble's data forced the scientific world to take Lemaître seriously. The term Big Bang was coined by critic Fred Hoyle, meant as an insult, but it stuck. Thanks to Lemaître's theory and Hubble's observations, science shifted from a static universe to one with a definite beginning. The cosmic egg had cracked, and the universe had burst forth. Now new questions emerged. What was this primeval atom? What happened in those first moments? The Big Bang wasn't an explosion in space. It was the rapid expansion of space itself. There was no outside for it to explode into. Space, time, matter, and energy all began together. Imagine the raisin bread again. Galaxies aren't flying through space, but space itself is stretching. The Big Bang happened everywhere at once because all of space was compressed into a single point. Asking what came before is meaningless. Time itself began with the Big Bang. The theory describes the universe's evolution from that first instant onward expansion, cooling, and the formation of structure. Picture a single, infinitely hot and dense point. Then in an instant it expands. Space stretches, energy and particles emerge, and as the universe expands, it cools. This cooling allowed energy to become matter, matter to form atoms, and atoms to clump into stars and galaxies. The Big Bang is the starting gun for the universe's 13.8 billion year history. It's not about creation from nothing but about the unfolding of everything. The universe's story is one of transformation, not detonation. Expansion and cooling are the engines of cosmic evolution. From that first moment, the universe was set on a path to complexity, and it all began with a single extraordinary event. After the Big Bang, the universe's story is one of cooling and complexity. In the first instant, all forces were unified, but physics as we know it breaks down. A burst of rapid inflation expanded the universe exponentially. As it cooled, quarks formed protons and neutrons. Within seconds, the first atomic nuclei appeared. In the first 3 minutes, hydrogen and helium were forged. For 380,000 years, the universe was a hot, opaque fog. Light couldn't travel freely. When it cooled enough for atoms to form, the fog cleared and light was set free. This ancient light, the cosmic microwave background, is still detectable today. Afterward, the universe entered the Dark Ages. No stars, just gas. Gravity slowly pulled gas together, igniting the first stars and ending the darkness. These first stars seeded the cosmos with heavier elements. The universe's baby pictures are written in light and matter, telling the story of our cosmic origins. A good theory makes predictions, and the Big Bang theory delivers, supported by 3 pillars of evidence. First, the redshift of distant galaxies, showing universal expansion. Second, the cosmic microwave background, the afterglow of the Big Bang, discovered by accident in 1965. This faint microwave signal is a perfect match for predictions, a baby picture of the universe at 380,000 years old. Tiny fluctuations in the CMB are the seeds of all future structure. Without them, no galaxies, no use. Third, the abundance of light elements. The Big Bang predicts a universe of 75% hydrogen, 25% helium, and traces of lithium, exactly what we observe in the oldest stars and gas clouds. These clues confirm the Big Bang story. The universe's chemistry, its light, and its motion all point to a hot, dense beginning. The evidence is written across the cosmos. The Big Bang theory explains much but leaves deep mysteries. It describes how the universe evolved, but not why it began, or what, if anything, came before. At the very beginning, our physics breaks down. We need a theory of quantum gravity to go further. Then there's the invisible, dark matter, the unseen mass holding galaxies together, and dark energy, the force driving the universe's accelerating expansion. Dark matter makes up 27% of the universe, dark energy 68%, while normal matter is just 5%. We know they exist from their effects, but their true nature remains unknown. These mysteries push science to its limits, inspiring ideas like the multiverse and string theory. The Big Bang has shown us how much we know, and how much we have yet to discover. The search for answers drives cosmology forward. The universe's greatest secrets are still out there. The Big Bang wasn't always the only theory. The steady-state model proposed an eternal, unchanging universe, but couldn't explain the cosmic microwave background. Other ideas, like the oscillating universe, imagined endless cycles of expansion and contraction. Today, inflationary theory and concepts like string theory offer new ways to understand the universe's beginning. Science is always evolving, refining its models as new evidence emerges. The Big Bang forces us to confront the biggest questions. What does it mean to live in a universe with a beginning? We are made of stardust, connected to the cosmos by our very atoms. Our existence is part of a dynamic, unfolding story, 13.8 billion years in the making. We are not separate from the universe. We are its curious children searching for our origins. The quest continues.